Hello, everyone. My name is Nitin Motgi, so I'm one of the group product managers in data analytics space. You guys have seen me on the keynote demo there. But if you have not, I'm going to show you what data fusion is all about. So before I get started, I wanted to give you guys enough context of where it's being used. So I wanted to introduce my colleague Robert here, who's from Telus Digital. So he's going to basically give you guys the context in terms of how they're looking to use data fusion. So with that, I will hand it over to Robert. See you guys in a few minutes.
And thank you, everyone. Hi. So I'm Robert. I'm a software architect with Telus Digital. If you're not familiar with Telus, it's a Canadian telecommunications firm that operates in the traditional telecom verticals. We offer phone, internet, mobile phone, television services. And won't surprise you to learn that in the course of conducting our business, we collect a very large amount and we generate a very large amount of data that we need to carefully and responsibly manage. That data also needs to be sifted for whatever insights we can glean in order to better serve our customers. So we're a growing business, and we're moving into new lines of business all the time. Some of those areas come replete with their own data-specific challenges. In some instances, we're confronted with particular security strictness that we have to contend with. In other areas, we have compliance and regulatory regimes that we have to deal with. In still other areas, we have particular data volume and velocity challenges that we need to contend with. So all of this is to say that over the course of our 100-year history and a number of mergers and acquisitions, where every new member of the family has come with new data standards, new data processes, systems, our landscape has grown extremely complex. This complexity has been very hard to contend with. You know, it's hard just to grapple with it, to grok it, to understand it, let alone to try and merge it all or fuse it into a unified whole. So to try and understand where some of the places we were falling short are, we recently conducted a survey of all the participants in our data ecosystem, from which we learned that the average score people were willing to give to our data and our data systems was a rather middling 2.74 on a 5-point scale. Not as good as it could be, unfortunately. The data that we received was rich enough to reveal an interesting pattern, which was that the closer you are to generating data, particularly if you're a human that only deals with a single database or a single data generating process, the happier you tended to be with your lot in life. If you're a person that was responsible for taking data and transforming it, somehow relocating it or handing it off, you were generally a little less content with your lot. And if you were a downstream consumer of data, you were generally somewhat unhappy. This is particularly if you needed to rely on a synthesis of data, cross-functional data from a lot of different upstream data sources. So generally speaking, the picture was that the higher you went in the organization and the more data you had to touch, the more unhappy you were. And since that describes senior level decision makers, we realized that we had a bit of a problem that we had to solve. The implication for us was that we needed to walk before we could run. We're very interested in exploring some sophisticated capabilities like machine learning. We wanted to build out an AI program, but we realized that before we could do any of that, we needed to fix our data problems. So the answer for us was to explore the principles of supply chain management and to undertake a data supply chain program. So building a data supply chain is replete with many challenges. Those challenges include the need to integrate data from a great number of sources. Integrating meaning clean, validate, refine, reconcile data through an often complex chain of lengthy transformations. We also have to handle the entire data lifecycle. Our data is born, it lives and is in active use, and it retires and eventually becomes obsolete. And during the entire course of this event, we need to avoid breakage. We need to provide a consistent and canonical view of data to our users, and in particular, we want to compute key business metrics just once and in just one way, if possible. We needed to better understand our data. We need an ontology to ascribe shared meaning to data. And in particular, we needed comprehensive metadata and lineage information about all of our data down to the field level for every field. We wanted to build a unitary system, something that supported many roles from less to more technical, without causing an explosion in the number of tools that we had to build or support. And we wanted something that was ubiquitous, something that lived in all the places where our data lived and made data location transparency pivotal. Ultimately, we needed safe and secure delivery of our data to our downstream consumers. We wanted to break out of all the data silos that existed in the enterprise. All of this has to happen in the context of a world where cloud is an important part of what we do, and we've learned that building hybrid cloud architectures is challenging. Some of those challenges include the need for portability. We need to build things locally, develop artifacts that we can run locally, but also run on-prem in our data lake, for example, as well as to move it into the cloud for the scaling and other benefits that cloud offers. We need to be able to distribute our data pipelines so they seamlessly bridge from on-prem to cloud so that our data can flow back and forth without any friction. We need extensibility. So we need standard hooks, well-defined places to add our own business logic, to add data transformations, to add connectors to various data sources, ideally without bespoke integration. Every bit of bespoke code that we have to write to support these things means an additional burden in terms of technical debt that we'd rather avoid. We have the problem of affinity. Some applications just resist hybridization. Some data sets have to be pinned to a certain location for various reasons. Conversely, some data has to be duplicated, and that comes with its attendant challenges of having a unified view of your data, maintaining data lineage, and so on. And the problem of testability is key. In as much as things vary from environment to environment, we want to isolate those things, test them once. We want to test once, not test once per environment, right? And we want sufficient abstraction that we can build our pipelines, build our data transformations, build our logic, test it once, and know that it's going to run in all the places where we need it to. So taking GCP as our example of a single cloud, we're here, why not? We realize that we suffer from an embarrassment of riches. The great number of services on offer mean that we are faced with service integration challenges. We're faced with a fairly steep learning curve. Building even a relatively simple pipeline, imagine landing data in GCS, modifying it with Dataproc, pushing it into BigQuery or Bigtable, and ultimately surfacing it in Data Studio. Recall what it was like to be a newbie to the platform and how daunting all of those things seemed, and then imagine having to stitch them all together. Right? This is something that we needed to come up with a way to address. All of this impacts our speed to productivity. The more things that we're touching and trying to stitch together, the greater our challenge. We want to find a way to make easy things easy, in spite of the fact that digging into specific tools yields benefits, greater performance, lower cost. We still need a way to tie things together without having to be deep experts in every single part of the data pipelines that we build. So multi-cloud, we live in a multi-cloud world, and there's no escaping it. This comes with the challenge of finding people that are sufficiently skilled. Finding folks that are knowledgeable about one cloud platform is hard. Finding unicorns that know and have deep expertise across multiple clouds is correspondingly more difficult. When things inevitably go wrong, finding the root cause of the problems is made much more complicated when your applications are parceled out across multiple clouds. And with the greater mix of tools and services available across clouds, you'll find that finding the right mix of things to tailor for precisely your application is more difficult. And of course, there may come a time when you want to move onto or off of a particular cloud. And to the extent that you've tailored your applications to the interfaces of those cloud, you'll find that you have a higher switching cost to pay. So the question before us is, can we find or build a tool to tie a broad array of services together near seamlessly across our on-prem and cloud infrastructure, multi-cloud infrastructure, in fact, in a way that minimizes the cognitive load of taking advantage of all this power? We want a platform that supports the end-to-end data lifecycle, something that helps us manage data from the moment of its capture till its eventual retirement. We want something that helps us better understand our data and processes, something that explains the origin and the lineage of all the data that flows through the system. We want something that supports a broad mix of less technical and more technical users, giving all of these folks a home, something within which they can easily access the data that they need and build flows to shape it in the way that they want. And to add on a few extra bullet points, if we could find something that was open source and that has a community, so much the better. If we can find something that we know scales from micro jobs all the way up to massive, and if we could find something that's sufficiently flexible that we can mold and shape it to our needs, we'd be that much happier. So about a year ago, I was introduced to something called CDAP. CDAP was an open source tool for big data processing, and having dug into it, I became very excited. It seemed to address a lot of these points that I've mentioned. And it wasn't so long after first encountering the tool and getting excited, I learned that it had joined the Google Cloud family of services and had become what you're going to hear about today, Data Fusion. Since then, Data Fusion has become an important part of our data integration efforts as we move our data supply chain into a hybrid and multi-cloud world. And Data Fusion solves a number of the pain points that we suffer, and I'd like to introduce Nitin to tell you a little bit more about it.
Thank you.
Thank you.
Thank you, Robert.
Thank you.
So let's talk about Data Fusion. So Data Fusion, what is Data Fusion? So Data Fusion is a fully managed cloud-native data integration service. It's basically helping you to efficiently build and manage data pipelines. With a graphical interface and a broad collection of open source transformations and hundreds of out-of-box connectors, it helps organizations shift the focus from code and integration to insights and actions. It's actually built on an open source technology called CDAP. CDAP has been in existence for quite some time now. This is a managed version of it. So we can talk more about CDAP in general, but CDAP as a platform, allows you to build data analytical applications. And as part of data analytical applications, there are a few analytical applications that are also included as part of CDAP, and one of them is ability to build data pipelines. The second one is more about how do you transform the data without having to write any code. We call them Wrangler, Data Prep. The name has been constantly changing. But it's an ability where if you are specifying transformations, you're applying data quality checks, you don't need to be writing any code. And that is another accelerator or an application that is built on top of CDAP. So there are more other things like that, like rules engine, a bunch of things like that, which we will look at it later. But what we have done now is taken those two parts with ability to build pipelines and an ability to do transformations without having to write code. And along with the CDAP platform, we have turned that into a managed offering on GCP. So when you look at the kinds of use cases that you can use to solve this and the problems that it is trying to address, first thing that it is trying to address, like Robert mentioned, it's making it extremely easy to move data around, right? So right now, if you're doing it all by yourself, it's very error prone. It's very time consuming. So if I have to move data from, let's say, GCS to BigQuery, I would have to spend a lot of time writing code and ensuring that that code actually works every single time. That's not to say if I have to do another such point A to point B transition with added transformation, I start all over again. So essentially, at the end of it, it increases your TCO, right? So just for moving, you're spending way too much time, and then you're actually getting into situations where you might not be able to address all of the business requirements that you have, right? And also, skills gap is another thing. So it's like you need to have right set of skills and have good expertise in the systems that you're stitching them together, right? Because there are performance requirements, there are a bunch of things related to how-tos, best practices you need to be adhering to. So all that is kind of very difficult, right? And the last one is hybrid. And hybrid is something that is very interesting. Actually, during our process through EAP, which is the early access program on GCP, we learned that actual journey to cloud starts on-prem. It's not like lift and shift and everything is done. It's kind of hard. You need to be able to start your journey slowly from an on-prem environment. So just by the combination of CDAP and Data Fusion, it allows you to do so. And you don't need to build it twice. You can build it once and be able to run them in two different environments. So who are the users that we are targeting with Data Fusion? Right? So we are leveling it up. We are moving the level up in terms of being able to adopt GCP and being able to apply transformations. When you look at when there is a need for developer, data scientist, or business analyst to cleanse, transform, blend, transfer data, or standardize, canonicalize, automate your data operations, data ops, we want you to be using Data Fusion. Data Fusion provides a graphical interface. With that, it also provides the ability for you to test, debug, as well as deploy. You can deploy it at scale on GCP. And there, we can essentially scale to your data levels, right? So it essentially can scale to petabytes of data there. Now, in addition to that, we also collect a lot of metadata, whether it is business, technical, or operational. All of this metadata is aggregated within Data Fusion. And we are exposing that in terms of lineage. So you will be able to do things like root cause analysis, impact analysis, be able to find provenance, right? Be able to associate a lot of metadata for the data pipelines that you're building, as well as data sets that you're creating with it. And that's a very important part of having data operations anywhere. So when you look at the kinds of use cases that Data Fusion is trying to solve, right? Data Fusion, these are different business imperatives that translate into IT initiatives and then maps to how Data Fusion can help solve. So when you're looking to build warehouses, you're actually trying to get data from many different sources. Let's say into BigQuery as an example. You should make it extremely easy to do that. It should not take you years, 6 months, not that long. You should be able to operationalize these things pretty quickly. When you are actually looking to retire legacy systems, Data Fusion can help you migrate that data over to GCP. It doesn't need to be just BigQuery. You can put it in Spanner, you can put it in Cloud SQL, Data Store, Bigtable. You can pretty much be able to connect to anything that is available on GCP to bring that data in. And it's not just limited from a sources perspective to on-prem. You can also read from the same set of sources that you have written to in GCP. Data consolidation is another aspect. So you're trying to either migrate some data or essentially delete or essentially retire a bunch of data that exists there. Master data management is something that has a bunch of capabilities, but we are going to be adding a lot more in this year to essentially help create a much more consistent, high-quality environment for your data. And the last one is extend or migrate in cases on a hybrid environment where we want to load shed into cloud. If you are still on-prem, you will be able to do those kind of things. The thing is the complexity of it, being able to run on cloud, on-prem, and in other clouds. That's the biggest part of all this. You should be able to run that across anywhere. So just to put it all together, so the way I like to think about this is Data Fusion is providing a fabric which allows you to fuse a lot of different technologies and products that are available on GCP in a much more easy, accessible, secure, performant, and an intelligent manner. It just makes the entire process extremely easy. So the things that would take me 6 weeks to build, I can literally build them in 2 minutes, deploy them on the third minute, and be able to operationalize. Operationalize should not be that easy, but like it takes, let's say, a day or so, right? So basically, this is bringing a lot of different things together, making it very simple. It's moving up the bar, lowering the barrier to entry, essentially for GCP, when you talk in terms of data. So with that brief introduction, I'm going to show you guys a demo of Data Fusion. So let's get started. So Data Fusion, as I said, is a managed offering. So it would be available through Cloud Console. So you will be, starting today, you will be able to see Data Fusion show up on the Cloud Console. So now, what we have done is we have basically taken Data Fusion and given 2 different editions. We have made 2 different editions available to you all. One is the basic edition. The second one is an enterprise edition. You should be able to pick depending on your needs. And we recommend basic edition to be more for dev, I would say, not so highly available QA environment, but enterprise edition is more for mission critical stuff. So you should be able to provision off of those 2 editions to start with. So here I have already created a few of them. I mean, these are all, you can see, these are next demo stuff. So a bunch of different things that have been created and all are enterprise. But I can go into create instance and be able to specify. And here are the regions that here are the zones and locations that we are starting with. So we have Asia East, Europe West, Central, east and west, all of these. So as we go along, we'll be adding more locations in this year. So once I create the instance, I can jump into Data Fusion entirely. So this is Data Fusion. It looks a lot like a cockpit where essentially you have a lot of things that you have interacted with. This is called a control center. Control center is the place where you are actually able to monitor and be able to manage all of your data sets and data pipelines. This is a central place for doing that. So you also have an ability to work with the pipelines. This is the list of explicit pipelines that you are interested in. Here we have put a few pipelines that have been scheduled to run, and they have been running. Additionally, you also have a studio where you can build different pipelines. It's a visual way of building all of these pipelines, being able to deploy them. And also, we have a place where we are collecting metadata. I skipped on one, Wrangler. I'll come back to that. This is where we are collecting all of the pipeline metadata as well as all of the different data sets. Data gets collected here. So the interesting part, now let's imagine you have data sitting in an Oracle system, right? So like it's an on-prem Oracle system and you want to bring data in. It's not just limited to Oracle, actually. We have hundreds of out-of-box connectors that allow you to connect to various systems, starting from mainframe to being able to connect to a bunch of different cloud sources, right? So in order to start with, so we have started providing a very simple way of bringing data in, right? So first thing you're seeing here is I have pulled in a data from an Oracle table. Now let's see how did we get here, right? So Wrangler allows you to connect to various different data sources. These are the popular ones. We are going to be adding a lot more in coming months, actually. So I have already pre-configured an Oracle table here. I can actually add more databases. Databases that can support JDBC can be easily added here. We also support Kafka, S3, GCS, BigQuery, and stuff. So as soon as your instance gets created, it automatically attaches to your project's GCS, BigQuery, and Spanner. So now let's say I have data sitting in Oracle here. So this is now live listing all of the Oracle tables, and I'm interested in bringing in one table only. Not to say that we have ability to also bring the entire database over. So you don't have to do one table at a time. You can bring the entire database over. So let me click on the employees table. As soon as I click, the data gets sampled. There are many different ways the data can be sampled. But the data gets sampled. All of the data types of the source data system gets translated into an intermediate, where essentially it's Avro, where it gets translated into Avro types. So it's basically an Avro spec, but it is an extended Avro spec to specify various other types. So now once I'm here, I can apply transformations. So now the first thing I see is commission percentage is being highlighted for, like, there's some data that's actually missing here. Now, for order to process, I want to make sure I can specify some default values. So I'm going to fill 0.0 here. So the commission, there's 0% commission. I can now see it's 100% complete, right? I can also see that the job ID is a combination of two things, department and title. So I want to be able to specify a way to split those. So I can go in here, I say extract fields by delimiters. So now it generated two columns, right? So I don't need this specific column from here, and I'm good, right? So now, but you want to get a little bit insight of how your data is organized. So we basically make it easy to get a little bit of insights on your data. So there is a way where you can essentially slice and dice this data in and have a visual way of looking at how the different dimensions are organized, how many data records are for a certain type. So you can drill down on these and look at and compare that with other dimensions, right? So this is just to give you a feel of how your data that you have pulled in or the sample that you have been pulled is organized. So once you are comfortable with this, I will say go create a pipeline, because my source right now is Oracle. It's not a real-time source, right? So it's a batch source right now because we are pulling it in batch, but you can also do real-time data pull from Oracle, so like if you're doing things like CDC and such. So I want to create a batch pipeline. So what that does is it transfers all the work that I did in Wrangler into my studio where I can author the rest of the pipeline. My goal was to get those transformations. Now, I started with Wrangler to create this, but you can go the other way too. You can actually go from being in this canvas or a studio to being able to wrangle that. So it's just by dropping one of the transforms, like Wrangler transforms here, you should be able to do that seamlessly. For simplicity, I'm just using a very simple pipeline. So if you want to be able to, let's say, now this is not going to be operating on just a sample. It's going to be operating on the entire table that you're trying to pull. So then I can go ahead and figure out, like, I need to put this into, let's say, BigQuery for analytics. I also want to make sure that I can actually store this data or archive this data into GCS. Right? So it's as easy as that. Now I configure these. Configurations are also pretty easy here. So you just define the configuration, which is your data set, your table name. That's all you need to specify. Those are the mandatory fields. You're done. That's how you essentially bring data into BigQuery. The same holds true from GCS perspective. You specify how your bucket needs to be there, what your suffix path is, and you can also define the format in which you want to write that data in. It's not limited to it. So now, the Wrangler that I specified, that I showed you guys, there are more than 1,000+ functions, which include a lot of data quality checks, which I'm going to show you guys. But the most important thing with that is it is extendable. You can write your own data transformation. We call them directives. You can write your own data transformation directives. And you can just drop them in and use them in any pipeline. Right? That gives you shareability. So to show that, let me see. After doing this, I feel like, oh man, I missed something. So I want to go back and do more operations here. Right? So I want to be able to say, like, things like, for example, this employee ID, change my type to, let's say, long. So I should be able to do those types of things. So I go back and I make those transformations, and I'm done with it. So let's see, I go back. OK, so all the transformations are here. So now whatever I have done can be configured. So right now, the pipeline, we provide 2 different ways of being able to execute the pipeline. You can run them as a Spark job. You can run them as a MapReduce job. But we are also going to be, in future, adding an ability for you to run that as a data flow job. So you build a pipeline. You'll be able to run in any of these 3 things without having to make any change to your business logic. Let that sink in for a bit. You then have an ability to specify resources. So like this is actually for MapReduce. OK, that's not that interesting. It's an old one. So let's go with Spark. So you can change how Spark behaves. So you can specify configurations. You can specify very specific. We don't recommend, actually, for you to do this. I'm just showing you that these are available if you guys are interested in fine-tuning your particular pipeline. We also do support alerts. So again, these alerts, we do provide a developer SDK that allows you to extend these and add your own thing. For example, one of our users actually wrote a Slack connector. So every time a pipeline finishes, it sends a Slack message. I think there was someone wrote a HipChat one, and there was Twilio one, like a bunch of things like that. So you can make the notifications pretty easy with these. So in addition to this, you also have the ability to schedule your pipelines from here. You can define them here, or you can define them once they are deployed. Now, the interesting thing here is you can actually debug the pipeline. As soon as you go into the preview mode, it provides you an ability to test your pipeline. And it actually is going to go to the original source, bring that data in. So right now, it supports n number. N is defaulted to 100 rows. But if you want to run on a larger sample, you should be able to do that. It just takes a little bit more time when you are looking to preview terabytes of data. But we are looking to improve that and essentially be able to do this constantly in real time so that you can look at the data as you are building the pipeline. So all of this actually translates. One question that I always get asked is this generating a Spark or MapReduce code? And is it a code generator? And my answer to that is no. It's not a code generator. I mean, I don't know how many of you guys know, but there's like the word that was coined a long time ago called code weaving. So it weaves all of the different components that are being built for one execution engine in an optimized way. So there is actually a planner that picks up all the bits and pieces and translates that into an execution plan. So it weaves all of the stuff that we're built into a pack. And it figures out what is our optimal way of transferring the data from one node to the other. In most cases, it's amazing because you're not going from one machine to the other. In most cases, you're actually doing in-memory transfers. And that's how it gets composed into the execution paradigm. And that's the same thing we can do for running it in Spark. We can do the same thing for running it in MapReduce. And with that, the ability for us to be able to push down some of those optimizations, or basically leverage the optimizations that are available in the underlying system, is extremely critical. And we are able to do that without having to make major architectural changes to this. Now, once a pipeline is built, you can actually see it generates a configuration, right? It's a simple JSON configuration. You can build it all by yourself with hand. It's not very complicated. It has just a few sections. And for everything there, in addition to being able to define the graphs, it actually tracks every individual node's the artifact version. So you can essentially track every component that is being used is being versioned, actually. So you are able to version every part of it. So if you come up with a new way of connector or updated, if there was a bug and you fixed it, you should be able to use that seamlessly. And the system allows you to migrate from version A to version B, making sure all of those checks have been handled carefully. So with that, this is essentially an ability to build a batch pipeline. But you can also do the same thing with real-time pipelines, actually. So you can build a bunch of real-time pipelines. Looks like there are a few, there are not that many plugins available here, but that's the reason we have added Hub. So Hub is a place where we will be adding more connectors, more transformations, more reusable components here that will be making it available here. And the best part is, you can have your own internal hub. So you can share some of the connectors or plugins that you're doing with with other users within your organization. It makes it extremely easy for you to do that. It's a spec that we ask you. It's actually documented spec. So if you can follow that spec, you can get in exactly the same market for your organization, in addition to what we do provide. And here, where we put stuff, these are a lot of things that we have built over the years, over the period of 7 years, but we are also getting a lot of contributions from within Google, our open source community, as well as we are working with a lot of partners to be able to build this. And the one important distinction that we are making, right? When I talk about data fusion is actually is unlimited user. Every instance, there is no limit on number of users who can access it. That's number one. Between basic and enterprise, we are not distinguishing connectors. Every single connector will be available in both of them, right? Unlike when you look at like how we essentially do connectors, generally we didn't want to give that choice. So it's essentially we wanted to keep it plain and simple, so every connector would be available of the things that we build. So from here, you want DB2 plugin, you can just deploy it. It gets added to your instance. That's it. With that, you are now able to use the DB2 plugin to talk to DB2 instances. So the same thing holds true. So there are a lot of different real-time connectors that are available. Transforms get shared. Analytics are different kinds, where you're actually doing joins, or you're actually aggregating data, you're profiling data. All that stuff is readily available. And the real-time pipelines actually, right now, when they run in GCP, they run as Spark streaming pipelines. Okay, with that, let me show you a little bit of a few things that you can do with this. So this is a very simple example of a pipeline that was deployed here, where you're essentially taking data from various different sources, joining them together, and writing it into a BigQuery. This pipeline has been scheduled to run. You get operational metrics on this pipeline. You're able to see how this pipeline is behaving over a period of time. All of this data that I'm showing you, all of the stuff that I just did from the UI, you are able to do those using REST APIs. Every single aspect of this is available through publicly available REST APIs. So if you're looking for something on this dashboard, it's actually available as a REST API for you to pull, so that you can integrate with your internal systems if you would like to. So now, if you see here, what's happening is when you ran this pipeline, actually this pipeline is using a data profile that's automatically created for you. So there is this notion of provisioner and profiles are based off of provisioners. So here is a profile that but the system automatically creates for you, and you can see using this profile all the different pipelines that are being executed and how much time they take from an execution perspective. So you can define different profiles for different kinds of workloads. You know, if you're doing large migration, you want to be able to say that you are doing heavy ETL transformations, you should be able to specify a profile for that. So something that can be controlled by administrators, but also, if needed, the users themselves can change them if they have the right permissions. So you have also the ability to look at every run of the pipeline. So this is just one execution of the pipeline, so I can go back in time. So we do keep, for long periods of time, all of this data in Data Fusion. And one important thing, so like this pipeline could be scheduled, right? This pipeline also can be triggered by the execution actions that are generated from the previous pipeline, right? So I can say, trigger this run of the pipeline only when the previous pipeline successfully completes, or it has just completed, or it has failed, then trigger it. So you have an ability to do that. And when you talk about different use cases where you're looking at many different teams involved in building a much larger pipeline, which is organization-wide, where there's a team A responsible for bringing data in from external sources, standardizing them, landing it in a staging area. And then from there, analytics team picks that data and runs their analytics or essentially do some aggregations and write them into BQ. Another team could be taking it from there, right? So now the thing is, information needs to be passed from one execution of one pipeline to the other. So for example, where you're landing on the staging area. So with tokens that are being passed between these pipelines, you are able to do that. And you can pick and choose which tokens you want to pass. I mean, this example, you have plugins you can pass, runtime arguments you can pass, you can even pass compute configs in there. So this is just a simple example of where you're doing all of the different joins. There can be far more complex pipelines you can build. So I want to show you guys one other pipeline. So this is a real-time pipeline, which is not running. It should be running. So this is a very simple real-time pipeline, which actually is taking data from, is watching for data that is arriving on GCS. As soon as the data arrives, it parses, cleanses the data, sends it to data profiling. It profiles that data for that window, whatever you have specified, right? Like if you specify a 15-minute or an hour data that's coming in, profile that, and that profile information is actually returned to PubSub. Now, all the good data gets returned to BigQuery, and any of the errors that were generated in the records or because of any bad data actually gets separated out and gets returned into GCS. So this is all is a real-time pipeline. Of course, it's a micro batch, but when we do integrate this with Dataflow, you will have true streaming capability, and you'll still be able to do these kind of stuff. So very simple things. This is how we are taking it to the next level. So this is an example of when a use case where you want to move the data, but you have no idea of the risk profile of that data, and you want to be able to make sure that if there is any sensitive data, you want to exclude that out before you send it to, let's say, your final data store, right? So this is something that we are going to be making it available soon in Q2, which is integration with DLP. So if I want to integrate with DLP, it's just drag DLP in, put it in there, configure it, your DLP work is done, right? Now, you might say, oh, how do we ensure that every data set that I have needs to be always be passed through DLP? So think of those two nodes, and you are essentially creating different kinds of data sets, right? Like, for example, this is a GCS one that's being sent to, let's say, DLP. So you will have the ability to create templates. You will take GCS and you will take DLP, and you create a template out of that. And what that will allow you to do is essentially be able to, anytime anyone uses that, it'll always be applying DLP transformations on that, or DLP filtering or tokenizations on that. So that is much more an easier way for you to club things. This is a very filter example. The filter example is actually allowing you to only filter data, but we'll be adding more capabilities in terms of being able to tokenize fields and such. So you'll have ability to, right now you say, with some confidence interval, which is like, filter confidence is low. Any time when there is credit card numbers that gets identified as sensitive data, filter it out. So I can pick and choose a bunch of different things. I will soon be able to also tokenize them, encrypt them, a bunch of things like that. So this is all great. So this is all about building the pipelines. I showed you guys how you can operationalize them, what are the metrics that are available. Logs are also similarly available in the same fashion. But the most important thing from an operational perspective is, can we actually monitor all of the pipelines in one place? So you have an ability to monitor, and there are more things that would be enabled soon. This is actually looking at all of the pipelines that are running on an hour by hour, and you'll be able to look at each individual pipeline and how they were being executed, what was their, what time did it take. In fact, we also include things like start delays. So what ends up happening is we had a lot of customers who schedule the pipeline actually to be running at, let's say, at 2 a.m. in the morning. Because it happens all independent of each other, the capacity within that project gets hit because everything starts around at the same time, right? So how do you avoid that? So this has a little bit of a futuristic view, one. Two, it also gives you an idea of how much time it is taking to start something up because the resources are not available. So you can actually go into future and look at what are the different jobs that are being scheduled at every hour, and what does that mean from a capacity perspective to be able to run that within that hour. So you get a visibility into those kind of things, which makes it extremely easy from an operations perspective. So one last thing before we go into Q&A session is the metadata that we talked about. So I can search. This is all in the context of integration, right? So this is all in context of integration, and I know you guys will have lots of questions around how does this integrate with data catalog. So let me give you an answer before you ask, but the whole idea here is both are a beta product right now, but at some point we would be making a read-only version of all of this metadata available in data catalog, number one. Number two, we'll still continue enhancing the experiences of solving the problems from a data integration perspective in data fusion. So that will still remain here. So things like deep lineage, field level lineage, a bunch of things that are very, very relevant to integration would still be available in here. So this is the data set that I was looking at. That was the join pipeline, and I can see the schema here. You can attach business tags. So this is like, I don't know. I'm just going to say double click here. So I should be able to immediately search based on that. You can look at lineage at a data set level, but the interesting is you can look at lineage at an individual field level. So you are able to actually figure out what happens to individual fields when the data is being ingested. So for example, if I'm looking at a landing page URL, this actually comes from a landing page data set. If I'm looking for a referral URL, it's coming from impression data set. If I'm looking at advertiser field, it's coming from an advertiser data set. But the interesting thing is, what are the operations that were being applied as the data was being moved? It went through different joins. It was read from this source. So our goal is to be able to write this in a normal, like an English text. So you can just read this to be able to see how your data is actually going to be moving. That is the goal. And we have basically starting to do that, but there's a long way to go in terms of making it full English text so that you can just read it. But you'll get an idea of where we are going with this. So just being able to look at where the data has come from and where it is going to go gives you a lot of flexibility to do that.